Hey everyone, and welcome to this explainer. Look, if you're a high school student gearing up for the IIT JEE, you already know the math section pulls absolutely no punches. It demands a rock-solid foundation, especially when we start dealing with those tricky topics that build a bridge between algebra and geometry. Have you ever felt like you're solving a math problem, you're doing everything right, and then out of nowhere, bam, you hit a complete brick wall where the numbers just stop making sense? Well, today, we're bringing out the sledgehammer for that brick wall, the absolute foundation of complex numbers. We're going to deconstruct the source material so you can see exactly how these numbers are built and represented, setting you up for total success on test day. So think about the standard number line you've been using for literally years. It's fantastic for counting, measuring, doing basic algebra, but it has a serious, fundamental flaw. It only lets you move in exactly one dimension, just left or right, forwards or backwards. But what happens when an equation forces you to step off that line entirely? For centuries, when early mathematicians bumped into equations like x squared plus 1 equals 0, they just threw their hands up. They called the problem broken, impossible. Fun fact, René Descartes actually coined the term imaginary as a derogatory insult for these solutions. No joke. But that one delimitation is exactly why we absolutely have to introduce a brand new, groundbreaking dimension to our mathematical toolkit.
All right, so here's our roadmap. First, we'll meet the complex number. Second, we'll see how to translate that into reals as ordered pairs. Third, we're going to map the complex plane. And finally, we'll lock in your IIT JEE Foundation.
Okay, let's dive right into this. Section 1, meet the complex number, specifically the A plus IB form.
Whenever you're dealing with complex numbers in your exam prep, you're almost always going to start with this fundamental algebraic representation, A plus IB. Now, don't let this new format freak you out. The letters A and B right here, they're just standard everyday real numbers. They can be positive, negative, fractions, decimals, whatever. The real heavy lifting for our structural mapping comes entirely from them. But we do got to acknowledge that little I. That's the legendary imaginary unit, the square root of -1, which is basically the key that unlocks this entire mathematical system. But the true magic for our graphing purposes happens when we bring A, B, and I together into this specific, unified format.
What's really brilliant about this is how it totally isolates the two separate identities that make up our single complex number. On the left side of the plus sign, we've got A. We call this the purely real part. On the right side, we've got IB. Now, the B itself is still a real number, but because it's glued to that imaginary I, this whole right side becomes the imaginary part. You kind of want to think of a complex number as this profound mathematical hybrid, like a mathematical centaur or a set of GPS coordinates, where two completely different species of numbers combine to give you one perfectly precise identity.
Let's transition over to our next core concept, Section 2, Reals as Ordered Pairs, introducing a new notation.
In math, an ordered pair is really just two real numbers written inside parentheses separated by a comma, like A comma B. But the word ordered is doing a ton of work here. The position matters immensely. The first number, A, has a completely different job than the second number, B. They're bound together in a highly specific relationship that we're going to use to decode our complex numbers. It's exactly like longitude and latitude on a map. If you swap them carelessly, you don't just get a slightly different answer. You end up stranded in the middle of the ocean instead of at your destination. If you're taking notes for your IIT JEE prep, this is a mental procedure you want to make completely automatic. So, how do we get from our algebraic hybrid to a clean ordered pair? It's just 3 super simple steps. Step 1. Look at your complex number in the standard A plus IB form. Step 2. Mentally strip away the I and extract just those two real numbers, A and B. Step 3. Drop them directly into your parentheses as the ordered pair A comma B. The real part always goes first, and the imaginary coefficient always goes second. Building this mental reflex is going to save you so much precious time on your exams.
Let's anchor this with a really concrete example. Take the complex number 3 plus 4i. Following our exact steps, we identify 3 as our real part A and 4 as our imaginary coefficient B. We extract them and boom, we instantly get the ordered pair 3, 4. Notice anything missing? The I is completely gone in the ordered pair notation. We literally don't need to write the I anymore because the pure geometry of placing that 4 in the second slot automatically tells the mathematical universe that it's the imaginary component. It's a highly efficient shorthand mathematicians use to keep the geometry nice and clean.
All right, we've got our ordered pairs, so let's bring them to life visually. Section 3, Mapping the Complex Plane.
Guys, this is where the true power of complex numbers reveals itself, and it is honestly a massive paradigm shift. By turning a plus ib into the ordered pair a comma b, we have suddenly gained a second coordinate. We are no longer trapped moving back and forth on that single restrictive 1D line. The complex plane absolutely blows the doors wide open. It expands our mathematical world into a massive open 2D map, giving every single complex number its own unique, exact location in two-dimensional space. We literally had to invent a new plane of existence just to give these previously impossible numbers a place to live.
Let's see how these coordinates act as turn-by-turn directions. Take our first example, 3 plus 4i, which became the ordered pair 3, 4. On our 2D map, that tells us to start right at the center origin, go right 3 spaces, and go up 4 spaces. Simple, right? Now let's walk through a trickier one, -2 plus I. The real part is -2, and the imaginary coefficient is a hidden +1. So our ordered pair is -2, 1. That tells us to move left 2 spaces and up 1 space. Every single algebraic equation translates perfectly into a map direction, no matter if the numbers are positive, negative, or a mix of the whole shebang. And this brilliantly illustrates the architecture of the complex plane itself. Just like the standard XY graph you're totally used to, we have 2 intersecting lines forming our grid. The horizontal axis is our real axis. It dictates our left and right movement based entirely on our extracted A. Your A handles the horizontal drive. The vertical axis is our imaginary axis. It dictates our up and down movement based entirely on our extracted B. Your B controls the vertical flight. Together, they work in absolute perfect harmony to construct the precise location of your ordered pair.
Okay, let's pull all of this together and bring it home. Section 4, your IIT JEE Foundation.
So, the crucial takeaway here, the absolute game changer that's going to elevate your studying, is recognizing this profound duality. For the IIT JEE, you cannot just view a complex number as a neat algebraic trick, and you certainly can't just view it as a random dot on a graph. You have to understand that the algebraic form, a plus ib, and the geometric form, the plotted point a comma b, are perfectly equivalent representations of the exact same mathematical entity. This duality is your secret weapon. When you're crunching algebra on the exam, you're actually flying a point around a 2D grid. Mastering that deep connection is exactly what separates the average student from the top percentiles.
Which leaves us with one final, pretty fascinating thought to ponder. Now that you know how to perfectly map a complex number as a specific point way out there on the 2D plane, how do you mathematically calculate its exact straight-line distance from the center origin? That pure distance is a seriously powerful concept, known as the modulus, and it's going to be the very next step in your IIT JEE journey. Master this map, and you will absolutely master the geometry of complex numbers on test day. Keep practicing translating your algebra into geometry, and you'll be more than ready for it. Thanks for hanging out with me for this explainer, and happy studying.
Welcome to this explainer. Okay, if you're a high school student gearing up for the IIT JEE, I'm sure you've heard the rumors that complex numbers are, well, complex. But honestly, today we're going to completely change that. We're going to demystify the core concepts of complex numbers to really kickstart your IIT JEE prep. We'll do this by turning abstract algebra into a highly visual map. By the time we're done here, you won't see these mathematical entities as confusing equations anymore, but as clear, easily navigable points on a grid. Let's get started.
Here is our agenda for today's visual journey. First, we'll meet the complex number. Second, we'll visualize the Argand diagram. Third, we'll calculate the modulus step by step. And finally, we'll understand the argument.
All right, Section 1, meet the complex number, the basic algebra. I want to challenge your perspective right off the bat, because getting this is going to help you grasp a whole new dimension of math. Think about it. Up until now in high school, you've probably always thought of numbers as simple quantities on a flat, one-dimensional number line, right? A number tells you how much or how far left or right you go. But what happens if a number represents an exact location in a two-dimensional space? It's a real game changer. Thinking of a number as a physical destination totally changes how we interact with it.
And that brings us to the basic algebraic form of that exact destination. It brilliantly combines both real and imaginary parts into a single entity. Whenever you see z, we're just talking about our complex number. And it's built out of two totally separate pieces, an a and an ib. Now, that I is the famous imaginary unit. It represents the square root of -1.
Fun fact, mathematicians actually thought this concept was completely absurd when it was first discovered. But rather than getting bogged down in the abstract theory, I really want you to look at this equation as just a set of precise instructions.
Now, what's really cool here is how we split these components up side by side so you can see their distinct roles. The real part, A, is your standard familiar number. It behaves exactly like the math you already know and love. The imaginary part, IB, acts as the multiplier of the imaginary unit I. Together, they don't just mash into a single regular number. Instead, they exist in a sort of partnership. You can kind of think of them like an address. You've got a street name and a house number, and they work perfectly together to give you one exact location.
Okay, moving on to Section 2. Visualizing the Argonne diagram, the map.
This diagram right here, this is your ultimate secret weapon for the IIT JEE exam. It allows you to take those intimidating abstract equations and turn them into a super clear visual landscape. The Argonne diagram is basically the environment where the algebra of complex numbers actually comes to life. If the equation z equals a plus ib is the address, well, the Argonne diagram is the map itself. By mapping the real part horizontally and the imaginary part vertically, we plot these numbers exactly like coordinates on a hidden map. Just look at how simple this transformation is, especially if you're a beginner. You already know all about the x and y coordinate plane, right? Well, on the Argonne diagram, the x-axis is simply renamed the real axis. That's where your a value lives. And the y-axis? That's renamed the imaginary axis, which is where your b value lives. Suddenly, the complex number z equals a plus ib isn't some strange piece of algebra anymore. It literally just becomes a plotted dot at the coordinates a, b.
Section 3. Calculating modulus step by step. Distance.
You can basically think of the modulus as your distance from home base. It measures exactly how far you need to travel. In strict mathematical terms, the modulus, which is represented by those absolute value bars around the z, is the straight line distance from the origin, 0, 0, to your plotted point at A, B. And here's a crucial thing to remember. It does not matter what quadrant your point is in, the modulus is always a positive length.
So here are your foolproof, step-by-step instructions to get a quick win on your modulus calculations every single time. First off, identify your a and your b from the equation. Let's say your number is 3 plus 4i. Your a is 3 and your b is 4. Simple enough, right? Second, square them both. So 3 squared is 9 and 4 squared is 16. Third, add those squares together. 9 plus 16 equals 25. Finally, just take the square root of that sum. The square root of 25 is 5. And boom, there it is. Your modulus, your distance, is 5. If you think about it, you'll probably realize this is literally just the Pythagorean theorem applied to our Argonne map.
Section 4. Understanding the argument, direction.
Now, if the modulus is your distance, the argument, or amplitude, is basically the angle of your compass guiding your path. Because let's face it, knowing you need to walk 5 units isn't very helpful unless you know which direction you're supposed to walk in. The argument gives you that direction. It's the specific angle created between the positive real axis, pointing directly to the right, and the line segment drawn to your complex number.
Now you've absolutely got to memorize this foundational rule for finding the principal value. Seriously, applying this is going to save you from some of the most common, tricky traps on the IIT JEE. In standard math, an angle can just spin around infinitely, but to standardize answers for the exam, we restrict our argument to the principal value. This means your angle has to sit strictly between negative pi and positive pi. If your point is above the real axis, you measure upwards and you get a positive angle. If it's below, you measure downwards and you get a negative angle. Staying strictly within this range is completely non-negotiable for finding the right option on a multiple-choice test.
So, as we wrap up this explainer, I really want you to think about how mastering this visual map today is going to empower you to solve massive engineering problems tomorrow. You aren't just learning abstract formulas for a test, you're actually learning the language of two-dimensional rotation. This is the exact math used to calculate alternating currents in electrical engineering, and it's the very foundation for advanced physics. Master the Argonne diagram, perfect those modulus steps, and lock down your principal argument. You totally got this. Keep visualizing, and I'll see you in the next explainer.